So let's work at finding some inverse functions. Now I'm going to start off with a really simple one, then we'll get to a more complicated one. The simple one that I want to find the inverse of is x plus 3. Now we should know the answer to this already, that we know that to undo adding 3 to something, we should subtract 3 from something. So we know ahead of time that our inverse should be x minus 3. But let's walk through the steps. What I want you to do first is, just to make sure that we're using the same terminology and everything, we're going to say, instead of f of x, let's write y equals. So let's write this as y equals x plus 3. No big whoop there, just so we're writing in x's and y's. We know that f of x means the same thing as y. Now step 2, and this is really important. Most of the time in math, every step that we do is equivalent to the step above it. And so we just shouldn't be changing anything. We're just rewriting it in some way, shape, or form. Step 2 in this process that I'm writing down is actually changing things. So what I like to do as far as my organization is I like to write down the word inverse. Here's where I'm actually finding the inverse. We find the inverse by just flip-flopping x's and y's. Anywhere that you see a y, replace it with an x. Anywhere you see an x, replace it with a y, and that's it. Because that's how we define what an inverse is. If xy is on the function, then yx is on the inverse, so they're just flip-flopping. So that's all we're doing here. Then we want to try to write this eventually as f inverse of x equals. We want to write it in function notation, which means we want to get the y by itself. So we're going to subtract the 3 to the other side. That's step 3. Step 4, replace the y with f inverse of x, because that's just the name of it. The name of this inverse function is f inverse of x. So instead of y equals, we can say f inverse of x equals. And that's our answer. So let's look at a little more complicated problem. Our steps are going to be the same, though. We're going to start off by saying, hey, let's just write this as y equals instead of f of x equals. So there's step 1. Now in step 2 is where I'm actually going to change something. So I'm actually finding the inverse. This is not equivalent to the step above it. I'm actually changing it. I'm flip-flopping x's and y's. Now I have the actual inverse. It's just not written in a way that I like it. So in order to write it in a way that I like it, I want to get the y by itself. So in order to get the y by itself, we don't like the fact that the y is in the bottom right now. So what I want to do first is I want to clear my fractions. You know, fractions suck, get rid of the fractions. So I'm going to multiply both sides of the equation by y plus 2. Oops. On the right-hand side, the y plus 2's divide out. Then I want to write what's left, because we kind of have a couple different approaches that are going to look different but be equivalent. So I'm going to write where we're at right now. We have x times y plus 2 on one side and 3 on the other. I'm going to write this twice because I'm going to solve this problem in 2 different ways, just to point out that there's 2 approaches you can take, and you can go ahead and do whichever one you like better, but to realize that they are equivalent. So on the left side, one thing that I could do here is say, let me distribute that x throughout. That's going to give me xy plus 2x equals 3. Now remember what your goal here is, that your goal is to get the y by itself. So anything that's not a y, we basically just treat like a number and say, all right, that guy right there, that 2x, treat him like a number. Subtract him to the other side. So the next thing is 3 minus 2x, or if you want to write negative 2x plus 3, whatever. Now to get the y by itself, we could divide both sides of the equation by x. That's going to get me y equals, which is what I wanted, 3 minus 2x over x. And then instead of y equals, we have f inverse equals. There's one answer. Now the other direction we could go, so going back up to the step that we had x times parentheses y plus 2 equals 3, the other thing we could do in order to get the y by itself is we could have divided by x at this step. is we could have said, let's get the x out of there. That's going to leave us y plus 2 equals 3 over x. And then we could subtract 2 from both sides. Then instead of y equals, we have f inverse equals. Now both of these are equivalent to each other. Both are 100% correct answers. Now I do bring this up though because on a multiple choice final exam, for instance, you need to recognize that they're equivalent. So for instance, from our first one on the left, if I were to distribute the x into both sides, then this becomes 3 over x minus 2, and we can see it's equivalent to the other one. Whereas if we have this one here and say, hey, if I want a single fraction, I would need to multiply by x over x to get a common denominator, we can see that he's equivalent to the other one. So two different approaches to the same problem, both work perfectly fine and both are correct.